Swayam Prabha. Digital India. Educated India.
Hello, welcome to this third lecture of Module 4 on Geological Construction Material and Cement Aggregate Reaction. In previous lectures, we have discussed about construction dimensional stone as well as crushed stone. Now in these lectures, we will elaborate about aggregate. In these lectures, we are going to discuss about aggregate and deleterious material. Friends, as you know, the deleterious material is playing hazardous roles. Regarding these lectures, we are going to cover about aggregate and classification, then specification, then about deleterious materials and their impact. We have already discussed varieties of construction materials as a dimensional stone, crushed stone. The crushed stone is widely utilized as ballasts, as a chip and as aggregates also. The aggregate is widely utilized for providing the strain to the concrete or strain to the structure or strain to the binders. You can see these are aggregate. These are aggregates of angular nature, durable, hard and strong. These materials are utilized to provide strength to the binder materials like mortar, like concretes, like concrete. When we are going to utilize crushed stone as aggregate, then this aggregate, here you can see this cartoon. When this aggregate we are going to mix with cement or any kinds of binders like lime, like surkhi. Particularly aggregate mixed with water and cement mixture is responsible for formation of concrete. These aggregate mixed with cement plus water and making this type of concrete. Concrete is containing these hard parts along with the paste of the cement water mix. These aggregates are actually responsible to provide strain to the concrete, and the concrete is responsible to bear the load of engineering structure. These filler materials in form of fragments, in form of chips, in form of fine grains is recognized as aggregate. This natural geological material mixed with cement and water for making of concrete is known as aggregate. However, the aggregate can be also used along with lime, along with other binders. As example, mortar. Mortar is a mix of cement and sand. Sand is also, we are going to recognize concrete because sand is going to provide the strength to the mortar. The coarse aggregates are the rock fragments we are going to utilize for making concrete. However, finer materials such as sand, such as fine sand, utilized as aggregate for use as a mortar to bind the dimensional stones or building stones and brick. The aggregate is responsible for strength of concrete, therefore the concrete should sufficient strength to support the load of engineering structures. Otherwise, the concrete is unable to bear the load if the aggregates are less in quantity on one side or weak in strength and undurable in term of durability. So what is the precautions we are going to take during the selection of aggregate? So the principal precautions here to avoid deleterious materials present in aggregate. Now question is, what is deleterious material? In simple sentence we can say that hazardous material to the stability of the engineering structures. The strained quartz or deformed quartz, chalcedony, flint, chert and other cryptocrystalline materials made up consisting of silica and oxygen, as well as some shell material, some wooden pieces, some glass pieces, some clothes and others are also considered as deleterious. As far as the presence of deleterious is concerned, related to aggregate recovered from natural geological materials or rocks, are recovered from the boulders, gravels, cobbles of river basin, is mainly having some minerals like quartz or some minerals belonging to the silicates. If the quartz is deformed in nature or strained in nature, that is hazardous. Cryptocrystalline in nature, also hazardous in nature when we are going to utilize such rocks containing these materials as aggregates. Then flint, chert, amorphous variety belonging to silica and oxygen, as well as some aggregates having some chemical solubility, as well as corrosional reaction or interaction with the lime present in cement, are considered as deleterious material. Generally, we are utilizing the aggregates belonging to igneous rock, belonging to metamorphic rock or sedimentary rock, mainly containing quartz. Therefore, it is important to see carefully about the constituents quartz and the nature of quartz present in aggregate. So the major siliceous deleterious materials are strained quartz, chalcedony, flint, chert, cryptocrystalline variety of quartz. Beside this, the present shell, the siliceous chert, the dolomitic limestone and some rocks soluble in water as well as soluble in presence of limes are generally considered as deleterious natural material. If we are going to categorize or classify aggregates, then broadly we can categorize aggregate in two categories. First is coarse aggregate and then second is fine aggregate. Now we are going to see about coarse aggregate and fine aggregate. The coarse aggregate, this type or these kinds of aggregate constituted of cobble, pebbles, gravels and coarse sand, generally recovered from river basin or recovered from recent geological formation, for example quaternary age, or some rocks rich in siliceous materials, and in general durable, hard and compact rock, full quarries, etc. These kinds of aggregate comprises of cobble, pebbles and coarse sand. The voids after setting and the size fractions and proportions are important parameter for the consideration. In case of concrete, the desired strength of concrete is actually function of quality of aggregate, and the quality of aggregate is defined by the strength and durability of the aggregate. However, the strength and durability of the aggregate is a function of inherent property of aggregate that defined based on mineral constituent, texture and packing. The aggregate should be free from deleterious materials including cement reactive minerals, chemical reactive minerals, water reactive minerals and minerals which are undurable with respect to time. All kinds of materials should be avoided during the selection of aggregate. Now we have certain technical parameters regarding the selection of aggregate, and the selection of aggregate is evaluated or estimated or assessed through crushing strength, impact, abrasions and soundness value. The strength, impact strength, abrasion, soundness and crushing strength are important parameters for weightage or evaluation of aggregates as per requirement. Then what about the sources of such aggregate? Number of times we have discussed, but as per requirement we can again look. Recent deposits of cobbles derived from hard and durable rocks are the natural source of coarse aggregate for making concrete or other purpose. Beside these recent deposits, we have rock quarries also, from which during the fragmentation and excavations the fragments available besides crushed stone, besides dimensional stones, we are going to utilize as a aggregate also. The deposits consisting of cobble, gravel, pebbles generally located in river valley, terraces and glacial deposit are from rock quarries in form of crushed stone. Quality of aggregate. The quality of aggregate, particularly coarse aggregate, varies from place to place depending upon the source rock or the source of the coarse aggregate from which these have been derived. Terrains of igneous and metamorphic rocks comprising granite, basalt, dolerite, schist, gneiss, quartzite and even marble, limestones are the main sources of good quality of coarse aggregate materials obtained from river valley as well as crushed stone from the quarry site. In general consideration, the crushed stones recovered from the boulders, cobbles, pebbles of river basins are considered more suitable because these boulders, cobbles, pebbles have already been subjected to wear and tear during their transportation from the source area toward the quarry side or allowable side or excavation site. As these boulders have already been subjected lot of abrasions, wear and tear, therefore durable and resistance and strong sufficient to utilize as coarse aggregate. Generally in hilly terrains, the houses are widely use such type of crushed stones from the river valley side to reduce the transportation as well as improve technical quality of the structures made up by such crushed stone. Erosion and transportation are responsible for aggregate accumulation in form of deposits, and two prime factors associated with formation of aggregate material in form of aggregate deposits. River borne coarse aggregate materials are suitable for low cement consumptions because these aggregates are suitable to provide sufficient strength to the concrete, and concretes we are going to ideally utilize as a supportive material to bear the load of the engineering structure. The river-borne coarse aggregate is suitable and containing low cement in construction work because they consume less cement and have better bonding capacity compared to the crushed rock having angular and uneven surfaces. One good example, here we can see the river valley boulders and cobbles utilized for making the aggregate regarding the construction of Lakhwar Byasi Dam, construction of Rihand Dam, construction of Tehri Dam. Particularly in case of Rihand Dam, the boulders recovered from the Renuka river was widely utilized for making the Rihand Dam site. However, the crushed stones recovered from nearby quarry from the quadratic sites was also utilized as a partial support to provide the aggregate regarding the construction of Rihand Dam. Similarly, the Lakhwar Byasi Dam also required some additional support from the crushed stone recovered from some mountainous area. The Tehri Dam have utilized aggregates taken from the river valley Bhagirathi located nearby Tehri and Koteshwar area. The problem with coarse aggregate is presence of mica, presence of strained quartz, presence of amorphous silica and oxygen containing material, presence of some shell materials, presence of some silty materials, etc. In 90-meter high Rihand Dam gravity dam in Uttar Pradesh, the presence of mica containing materials as a schist belonging to the Mahakoshal group was not found suitable for the constructions, required lot of screening and lot of preparation, etc. regarding the construction. So regarding coarse aggregates, we have already elaborated about the utilization, about the availability of the deleterious materials, then some technical specifications we will discuss in our other forums also regarding this lecture. The fine aggregate, and we have major fine aggregate is a sand size fraction. The igneous terrain is suitably gives such type of sand size grain in form of coarse as well as fine. The sands are mainly consisting of quartz, feldspar and some other minerals. In this, quartz and feldspar are dominating. In domain of time, the feldspar is unable to bear the attack of moisture, water and others, started deteriorating when exposed to atmospheric oxygen and changes in form of cell. As far as the fine aggregate is concerned, these aggregates can be recovered from the sedimentary terrain and from the metamorphic terrain. From the metamorphic terrain as byproduct, as a result of the crushing and others, and in sedimentary terrain, particularly in recent river deposits, we have huge quantity of sand available, and some recent deposits belonging to glacials and others are also having fine sands materials. The sands and gravel deposits contain deleterious materials such as organic matter, coal, peat, clay, lump, soft shell and mica, as well as some mineral soluble rock fragments, etc. As per Bureau of Indian Standard Specification, these deleterious material in fine sands aggregate cannot exceed 5%, means should always less than 5%. For example, in case of Umiam project located in Meghalaya, in case of Little Ranjit project of Sikkim, the fine aggregate present in river was not found suitable due to presence of mica as well as clay. Therefore, the authority responsible for construction of Umiam project of Meghalaya as well as Little Ranjit project of the Sikkim recommended the nearby rock exposures for making of finer and coarse aggregate from the quarry side. And some of the material crushed rock mixed with the sand recovered from the river valley nearby the Umiam utilized for construction of this Umiam project as well as Ranjit project also. So we always careful about the presence of deleterious material and how to avoid or screen or separate deleterious material to ensure the future stability of engineering structure. Friends, these materials I have prepared with help of book, Engineering Geology book written by Gangopadhyay S, published from the Oxford University Publications. Is a good book, thick book, having page 12549. Then supports from the similar engineering geological book in name of Engineering Geology, written by Well FG in 2007, is also a thick book having page 12551. Then partial supports from the textbook of Engineering Geology written by Kashabolu and C in 2016. And then partial supports from the book based on the foundation of engineering geology written by Waltham T in 2018. Is a thin book but provided the summary to the every aspects of the engineering geology. Friends, we have already discussed about aggregates. If we try to conclude, we can conclude aggregate is a backbone of concrete, particularly coarse aggregate. However, fine aggregates are the backbone of mortar, similar to the coarse aggregate in concrete. However, the aggregates can be broadly categorized in two categories, coarse aggregate and fine aggregate. The coarse aggregates are widely utilized for making concrete. However, the fine aggregates are utilized for making concrete as well as mortar as well as concrete. The aggregate provide strength to concrete as well as engineering structure. Generally, coarse aggregate provide strength to aggregate. However, fine aggregate provide strength to the concrete as well as mortar and concrete to support the engineering structure. Deleterious materials are hazardous to the strength and durability of concrete, hence indirectly the stability of engineering structure. Dear friends, in this class we have discussed about aggregates, classification of aggregate, technical specifications required to evaluate aggregate in different categories. These based on crushing value, impact value, abrasion and soundness specification. The aggregates can be categorized in two categories, coarse aggregate and fine aggregate. However, the coarse aggregate is providing strength to concrete and the fine aggregates providing the binding capacity to the cement paste for binding the masonry as well as providing the strength to the concrete. The fine aggregates are widely utilized for mortar and concrete to bind the masonry, bricks, etc. Then we have elaborated about the deleterious material. Deleterious materials are hazardous in nature and should not be more than 5%. In these lectures, we have discussed how we are going to utilize natural geological materials as construction material for our future development after discussion related to the interaction of aggregate and cement in our future classes. Thank you very much for your patience hearing. Thank you.